This is a paper review for test number 3, and I'm starting with question 1. The directions say to solve the right triangle using the information given. So we have a right triangle, and we know that side B equals 8. So I'm going to go ahead and write that in. And angle A is 30 degrees. Now I have to find angle B, side C, and side A. Okay, since it's a right triangle, I can use trig to figure out a missing side. So I know I have an angle and I have side B. Let's say I'm going after side C. Well, if I'm looking at angle A, side B is adjacent and C is the hypotenuse. So the trig function that links up adjacent hypotenuse is cosine. So cosine of 30 degrees equals A, adjacent, which is 8, over the hypotenuse, which is C. Now I have to solve for C. So C equals cosine 30 degrees equals 8. I meant to say C times cosine 30 degrees equals 8. So C equals 8 divided by cosine of 30 degrees. So now I'm going to use my calculator to figure out what that is. Make sure before you plug anything in that your mode is in degrees, which mine is. So I do 8 divided by cosine of 30 degrees. And when I do that, I get 9.2376, but it said round to 2 decimal places. So C, or side C, is 9.24. Okay, so now that I have side C done, I can choose either to use Pythagorean theorem, a squared plus b squared equals c squared, to find the missing side A, or I can use trig functions again. So let me just erase this so it's not highlighted anymore. If I go after A and I use the given side B, now A, according to angle A, is opposite. So I need a trig function that links up opposite to adjacent, which is tangent. Okay, so side A. So tangent equals opposite over adjacent. So tan of 30 degrees equals opposite, which is A. We don't know what that is. And adjacent, which is 8. So 8 times tangent of 30 degrees equals A. Again, make sure that your calculator is in degrees. And when I do that, I get side A equals 4.618. Rounding to 2 decimals, it's 4.62. So now I have side A, side C, and now I just have to find angle B. Okay, since we have a right triangle, we know that the interior angles of any triangle is 180 degrees. And I know since the one angle is 90 degrees, that B plus A have to equal 90. So if A is 30 degrees, then B has to be 60 for that to equal 90 degrees. And I do 90 minus 30, which equals 60 degrees. So now I have angle B, side C, and side B, or excuse me, and side C. So A, B, and C, all the sides are found, and angle B is also found. So that was number 1. Okay, let's move on to number 2. So number 2 says solve the triangle. And I got to draw this out really quick. Solve the triangle. So I have angle C, angle B, and angle A. And then side A is across from angle A, side B is across from angle B, and side C is across from angle C. C was 75 degrees. Angle A is given as 55 degrees. Side B is 5, and we have to find the rest. So first things first, I'm going to have to go after angle B. I know that some of the interior angles of any triangle is 180, so I do 180 minus 75 minus 55. That should give me angle B. So this is basically angle B, 180 minus angle A, and it's actually angle C minus angle A. to get angle B. Okay, so let's go ahead and figure out what that is. So 180 less 75 less 55 will give me 50 degrees. Okay, so 50 degrees is what angle B is. Okay. All right, now I have to find side A and side C. I'm going to use angle C and this given side B to figure this out. So I'm going to go after side A first. So I need a trig function that links up these two values, but I'm noticing this is not a right triangle. So I can't use SOHCAHTOA, I can't use sine, opposite over adjacent, etc., because that's only good for right triangles. Since this is not a right triangle, I have to use either law of sines or law of cosines. I see that this is a case of angle, side, angle. That's what's given. So therefore, it's not sassy snake, so I know I have to use law of sines. Okay, so law of sines says sine of angle C over C equals sine of angle B over B. And it equals sine of angle A over A. Okay, I know angle B now, and I know side B, so I can use this piece of it. Now I'm going to have to go after one of the other ones. I think I'm going to choose to do A first, so I'm going to use this piece of it. So I'm going after side A. So sine of angle B over B equals sine of angle A over A. So sine of angle B, remember, is 50 degrees. We just found that. Over side B, which is 5. And that equals sine of angle A, which is 55, over side A, which I don't know. And this becomes 5 times sine of 55 degrees equals A times sine of 50 degrees. So 5 times sine of 55 degrees divided by sine of 50 degrees will give me A. So I'm going to punch that into the calculator. I'm going to put parentheses around the numerator. So parentheses 5 times sine of 55 degrees, end parentheses, divided by sine of 50 degrees. And when I do that, I get A equals 5.346. Rounding that up, I get 5.35. So that's side A. Now, I have to also get side C. So I'm going to do the same process. I'm going to use law of sines. I'm going to use sine B over B. But this time around, I'm going to do sine C over C. All right, so sine of angle B, remember angle B was 50 degrees, over side B, which is 5, over sine of angle C is 75 degrees, over side C, which is the unknown. So C times sine of 50 degrees equals 5 times sine of 75 degrees. So C is equivalent to 5 times sine of 75 degrees over sine of 50 degrees. Okay, again, use parentheses. So 5 times sine of 75, end parentheses, divided by sine of 50 degrees. And when I do that, I get 6.304. 6.30 is rounded off, and that is side C. So I'm done with number 2. I have figured out what the missing sides were and that missing angle. Okay, thanks for watching. I'm going to pick up on the next video on number 3.